Dear viewers, welcome back to Operating System video lecture sessions. In this lecture video, we are going to discuss about one of the CPU scheduling algorithm, that is round robin scheduling algorithm. So in the previous lecture videos, we have discussed basic concepts, scheduling criteria, and the different scheduling algorithms like SJF, FCFS, priority scheduling algorithms. So objective of this lecture videos is to introduce the CPU scheduling algorithm, different CPU scheduling algorithms, and how to apply these scheduling algorithms onto the given case studies. Outcome of this video lecture is how to apply round robin process scheduling algorithm and calculate the average waiting time for the given processes. Round robin scheduling algorithm. This is one of the scheduling algorithm. Round robin is a preemptive process scheduling algorithm, and each process is provided a fixed time to execute it, that is called as a time quantum. Once a process is executed for a given time period, it is preempted and other process is executed for the given time period. So you know what is preempting and what is context switching. So context switching is used to save the state of the preempted process. So timer interrupts every quantum to schedule the next process. So let us check this round robin scheduling algorithm with an example, and the quantum time here is 4. So let us check with this example. See, 3 process has given to us: process 1, process 2, process 3, and process 1 burst time is 24, process 2 burst time is 3, and process 3 burst time is 3. So according to round robin scheduling algorithm, whatever the process is in the ready queue, that will be taken first, right? So if it is a ready queue, in the ready queue, process 1 is first, and the quantum time for this process 1 is 4. So here process 1 has taken 4 units of time. Immediately the process 1 will be preempted, and process 2 will be entered into the CPU, and this process 1 is kept here in the ready queue, right? Then process 2 will be completed. Process 2 needs only 3 units of time, so it will complete its burst time. Then process 3 is in the ready queue, so process 3 will come to the CPU, and it will execute its complete its burst time. Then in the process queue, it is P1. P1, it is already completed 24 units of time. So 20 units of time is remaining. So it will take 4 units of time, 4 units of time, again 4 units, 4 units, 4 units, because there is no other process. There is only one process, that is P1. So by the end of your Gantt chart, P1, P2, P3, 3 process will complete their burst time. So now you can calculate the average waiting time. You already know it, how to calculate the average waiting time, right? So you know what is context switching. So when you are using this round robin scheduling algorithm, the main key point here is time quantum. So if the time quantum is low, like the time quantum is only 1, so there are many number of context switches will be occurred. See, here it is 9 context switches. If the time quantum is 4, if the time quantum is 6, there is only one context switching, process 1 to process 2. If the time quantum is 12, the context switching is 0. This is the number of shows number of context switches. So obviously the context switches number is less, then the CPU efficient or performance will be good. So this is we already know about it. Right. So we will go with one more example here. Let me write one more example here. Okay, so take several process here. We'll check with, we'll try to understand with some more examples. Process and arrival time, and burst time. Process, arrival time, and burst time. So process 1, process 2, process 3, process 4, process 5, process 6. So for the process 1, the arrival time is 0, process 2 is arrival time is 1, process 3 is arrival time is 2, 3, 4, and 5. What are the burst time? Burst time is 4. Its burst time is, let us say, 5. Its burst time is 2. Its burst time is 1. And P5 burst time is, let us say, 6. P6 burst time is 3. So these are the burst times. And now, see, let us see this ready queue. We will try to draw the ready queue. Okay. At the 0th time, what is the first process here? It is process 1. P1 is there, right? At 0th time, at one interval of time, P2 has entered. At second interval of time, second unit of time, the P3 has entered, and so on. Now, considering this, we'll try to draw the Gantt chart for this one. Now, draw a line, that is timeline. At the time of 0, P1 has entered, and let us say its quantum time is 2. Quantum time is 2 units of time, right? Let us, capital T is equals 2 units of time. So P1 will take 2 units of time. So by the completion of B1 time, only P3 has entered. So there is P1, P2, and P3 are only there in the queue, right? So P4 has not entered. So when you are preempting, this P1 will enter into the ready queue. Here, this will enter. Then, right, after this again P3. Okay, let us see. So P1 completes 2 units of time, then P2 is there readily there because P3 has already there, but P1 will take, arrival time is 1 and its execution time is 5, will take 2 units of time. Again preempt P2 and add this P3. Okay. P3 will also take 2 units of time. So it is 0. Then after P3, you have to take P1 because in the ready queue, P1 is there, right? P1 will take 2 units of time. Then P4 will take only 1 unit of time. So 9. Then P5 will 2 units of time, that is 11. Then P2 will take 2 units of time, that is 13. P6 will take 2 units of time. Again, we will take P5. It is of 17 units of time. This is the continuation. Then after that, P2 will come. Then it will take 1 unit of time because there is only 1. So already 4 units of time completed, only 1 unit of time is there. So P2, then P6. P6 is also having only 1 unit of time. Then after that, P5. P5 will be there and it's 21 units of time. Now this is the Gantt chart. Now you have to calculate the waiting time for each and every process and average waiting time. Waiting time and average waiting time. Waiting time and average waiting time I have already explained in the previous lecture video. So please go through with it and try to calculate the average waiting time for this problem. Okay, and in addition to this, you're also given with one more problem here. So in this exercise problem, I have given 6 processes here, and it's different arrival times and its burst times. So when you observe this one, see, there is no process has entered in a 0th time unit and 1 time unit. So this is completely blank. Okay, it has started from 2nd unit of time. Okay, so try to complete this exercise problem. With this, we have completed round robin scheduling algorithm. Thank you.